Welcome back. Welcome to another lecture on GATE 2021. And in this lecture, we will do some problems related to Laplace transform. So we will do some problem related to Laplace transform. Let us do the problems. So it is given that the Laplace transform of ft, there is a function, there is a continuous time signal ft, and the Laplace transform of ft is given as s plus 2 divided by s square plus 1, where this L denotes the Laplace transform. So in short it is written, so it is from GATE, some previous year GATE question it is. So that L is basically that it denotes the Laplace transform. It denotes the Laplace transform. So this Laplace transform of ft is given, and also we have given another time domain function gt, and the Laplace transform is given. That Laplace transform is given as s square plus 1 divided by s plus 3 s plus 2. So this is this information is provided in the question. Now find out the question. Find out the Laplace transform of ht. So find out Laplace transform of ht. And the ht is given as ht is equals to 0 to t ft g t minus capital T dt. So this is a ht that is given. And now what we need to find out? We need to find out the Laplace transform of ht. We need to find out the Laplace transform of ht. So let us do this problem. So Laplace transform of ft is provided in the question, and that is equals to s plus 2 divided by s square plus 1. That is provided. And Laplace transform of gt is also provided, and that is equals to s square plus 1 and s plus 3 s plus 2. That is provided. Now we need to find out the Laplace transform of ht. Now we can understand that the Laplace transform of ht is basically the ht is given as 0 to t. It is ft g t minus capital T into dt. So it is if we talk in terms of unilateral Laplace transform, then it is nothing but ft convolution with gt. It is nothing but ft convolution with gt. If we take the unilateral Laplace transform, if we consider it is considered because that Laplace transform is taken. So basically that unilateral Laplace transform is considered in this question. So it is a unilateral Laplace transform. So basically this is unilateral equation. So we can find out the unilateral Laplace transform. So what is unilateral Laplace transform of ft? That is equals to Laplace transform of ft, that is fs. Let it is denoted as fs, and let it is denoted as gs. So it is nothing but the basically the convolution in time domain is equals to multiplication in s domain. So it is nothing but it is equals to fs multiplied by gs, because the convolution in time domain, because the convolution in time domain because the convolution in time domain is equal to the multiplication in S domain, is equal to multiplication in S domain. So this Laplace transform of St is Hs, and Hs is equal to Fs multiplied by Gs. So finally, what is Hs? So Hs is just we are going to substitute the value of Fs and Gs. So the substitute this value of Fs is S plus 2 divided by S square plus 1 multiplied by Gs, that is S square plus 1 divided by Es plus 3, Es plus 2. Now it is cancel out and this also cancel out. Then finally what we will get the Hs is equal to 1 divided by S plus 3, and that is nothing but the Laplace transform of Ht. So this is our solution. So the Laplace transform of Ht is equal to Hs, and that is equal to 1 divided by S plus 3. This is our final answer. This is our final answer. So all these types of questions are they are regularly asking in the GATE exam. Now let us do another problem. Let us do another problem. So the problem is, if Laplace transform of Ft, if the Laplace transform of Ft is given as pi divided by, the Laplace transform of Ft is given as pi divided by S square plus omega square, then what we need to find out, then the value of limit t tends to infinity Ft is, so we need to find out the value of limit t tends to infinity Ft. That is, we are going to find out the final value basically. So basically we need to find out the final value of, we need to find out the final value of Ft. So if we just consider the final value theorem, but so what is final value theorem? So it says that limit t tends to infinity Ft, that we need to find out, is equal to limit S tends to 0 as Fs. That is the final value theorem. So if we analyze this problem, then we can find out that this Fs is already provided. But what is Ft? What is Ft? So that Laplace transform is provided, Laplace transform of Ft is provided, and that is Fs, and it is equal to pi divided by S square plus omega square. That is provided. Now can we find out that what is Ft? Because if we find out the Ft, then we can find out, because directly applying the final value theorem will give us wrong result. I will show you everything, but first we need to find out the value of Ft. Let us find out the value of Ft. So Ft so Laplace transform of Ft is given, that is pi divided by S square plus omega square. Then what we can do, we can just divide and multiply it by omega. So it is equal to pi divided by omega, and it is equal to omega divided by S square plus omega square. So we can use the relation, that is Ft, if Ft is omega naught divided by S square plus omega naught square, then this is Fs, then Ft is nothing but sine omega naught t into ut. So basically the Laplace transform of this ft, that is sin omega naught t into ut, is nothing but omega naught square divided by s square plus omega naught square. So we can use this relation. So if ft is sin omega naught t into ut, then the Laplace transform of this ft is omega naught divided by s square plus omega naught square. So we can use this relation. So the Laplace, basically the inverse Laplace transform of this expression. So the inverse Laplace transform, what we will get? We will get pi divided by omega and sin omega naught t into ut. This will this is our ft that we get. Now if we just if we see that this expression, so this is basically a sinusoidal sequence. And due to multiplication of this ut, it only exists in positive side. So this is ft with respect to t. Now if we analyze this signal, we can find out that amplitude will range from plus minus 1. Plus 1 is the maximum value of sine, and minus 1 is the minimum value of sine wave. Okay, but here it is a multiplication of pi by omega. So this maximum value of this is plus pi divided by omega, and minimum value is minus pi divided by omega. So basically the final value, if we want to final value, that is if we want to limit t tends to infinity ft, then we can't say that there is a fixed value, because it is a sinusoidal signal. What is the value will range from plus pi by omega to minus pi by omega. We will get the value from the value will range from plus pi by omega to minus pi by omega. So the limit t tends to infinity ft, that is final value. So again I am writing so limit t tends to infinity ft basically cannot be determined exactly. So again if we apply the final value theorem directly, so limit t tends to infinity ft is limit s tends to 0, s and fs is provided, that is pi divided by s square plus omega square. Now if we apply the limit, so what we will get? We will get that 0 multiplied by pi divided by 0 plus omega square, that is 0. But it is wrong. Result. So directly directly applying the limit will give us the wrong result. So because that value will range from plus pi by omega to minus pi by omega, and we are not in a position to correctly determine what is the final value we are getting. Okay, so the answer is the limit t tends to infinity ft cannot be determined for this particular question. So let us do another problem. The problem is the Laplace transform of ft is provided, and it is equals to 2 multiplied by s plus 1 divided by s square plus 2s plus 5. So that is provided. Now what we need to find out? Then we need to find out initial value, that is f0 plus, and final value, that is f0 that is f infinity. We need to find out initial value and final value. So let us solve these two let us solve this problem. So this problem, to find out the solution of this problem, first we need to find out the poles and we need to check the stability. If the system is stable, then there is no problem to find out the value of initial and final value. So let us discuss the stability of this question. So if we find out the poles, so the Laplace transform of ft is given, and that is equals to 2s plus 1 divided by s square plus 2s plus 5. Now, if we analyze this question, then we can find out that all the poles exist in left hand side. All the poles will exist in left hand side. So that system is stable. And also we can say that that degree of numerator is less than the degree of denominator. So everything is fine for this problem. Now the initial value of 0 plus is equal to limit s tends to infinity s into fs. That is the initial value, and that is equals to limit s tends to infinity s into fs. So we can put the value of fs here, and it is equals to we can use the L'Hospital rule. So before that we can write it in this form. Just we can multiply s to all these things. So it is 2s square plus 2s divided by s square plus 2s plus 5. Now if we apply the L'Hospital rule, what we will get here, we will get 2 plus 0 divided by 1 plus 0 plus 0. Please check this. Please apply the L'Hospital rule. We will get the value, the initial value we will get is 2. So the initial value, that is limit t tends to 0 plus, that is f t tends to 0 plus ft, that is f0 plus the initial value is equals to 2. That is initial value. That is nothing but the initial value. That is initial value of function ft. That is initial value of function ft. Now we need to find out the final value. So that is limit t tends to infinity ft, and that is equals to f infinity is nothing but limit s tends to 0 s into fs, and that is not that is equals to limit s tends to 0 s into fs. So what is the value of fs? It is 2 s plus 1 divided by s square plus 2s plus 5, and that is nothing but it is equals to, if we apply the L'Hospital rule. So if we apply the L'Hospital rule, what we will get here, just we can check. It is limit s tends to 0. First we can just multiply this all these terms, and we can separate this. We can open out this bracket. So it is 2s square plus 2s divided by s square plus 2s plus 5. Now we can apply the L'Hospital rule, and what we will get? We will get it 0. Please check. We apply the L'Hospital rule and we will get the value 0. So the final value is 0. So f infinity is 0. The final value is 0. Let us discuss another problem. Indicate whether the following. The question is indicate whether the following statement is true or false. Is true or false. Give reason. Also we can give the reason for our answer. Also we can give the reason. For the answer. So it is also the previous year gate question. The question is if GS is stable, if GS is stable transfer function, if GS is stable transfer function, then Fs is equals to 1 divided by GS is always a stable transfer function. So basically we need to verify this statement. So Fs is so GS is given. So GS is given that it is stable. It is stable. So GS is given that it is stable transfer function. Now Fs is stable or not, it is defined, it is basically decided by the poles. So for a stable system, what is the condition? So for a stable system, all the poles should lie in left hand side plane. So all the poles should lie on left hand side, means that pole should not be on right hand side. If any pole is on right hand side, then the system will become unstable. Now GS is stable, it means if GS is stable, that is given in the question, if GS is stable, it means all the poles are exist in left hand side only. All the poles exist in left hand side only. It means that if we consider Fs and that is equals to 1 divided by GS, then it is not necessary that all the poles are exist only in left hand side. Maybe some poles may go outside, may go right hand side also. So it is not necessary. If we consider Fs another function, that is 1 divided by GS, so it is not necessary that all the poles will exist on left hand side only. There may be some poles that may exist on right hand side also. So there may be pole that may exist in right hand plane also, so that means that the system will become unstable. If right now GS is stable, but Fs may or may not be stable. So the conclusion is that Fs may or may not be. So Fs may or may not be stable. It is not necessary that if GS is stable, then Fs will also be stable. No, it is not necessary. Fs may or may not be stable. So let us do another problem. The problem is a system is described by the following differential equation. A system is described by is described by following differential equation. The equation is dyt divided by dt plus 5yt is equals to ut, and y0 is given. So the initial condition is given, and ut is unit step function, So the question is find yt, find the value of yt. So let us discuss this problem. So dyt divided by dt plus 5yt is equals to ut, that is given. We can take Laplace transform on both sides. So taking Laplace transform on both sides, so we get sys minus y0 plus 5 into ys is equals to 1 by s. That is Laplace transform. Basically the Laplace transform of ut is 1 by s, and the Laplace transform of x dash t or g dash t is equals to s gs minus g0 minus z0 or 0 minus. So gs is the Laplace transform of gs is basically the Laplace transform of gt. So this is the formula, this is the general formula we have applied in this. Now we can collect ys terms together. So ys s plus 5 is equals to 1 divided by s, and the value of y0 is 1, so it is 1 divided by s plus 1. So ys is written as s plus 1 divided by s plus 5, and that is equals to a divided by s plus b divided by s plus 5. So a is written as limit s tends to 0 s into ys at s is equals to 0. Whatever we are getting, we will put the s equal to 0. So what we will get? We will get 0.20. Please check. And similarly, the value of b we will get is minus 0.80. Please check these two values. Now that ys is written as, so ys is written as 0.20 divided by s minus 0.80 divided by as plus 5. So yt, so taking inverse Laplace transform, so yt is nothing but 0.20 into ut minus 0.80 e raised to the power minus 5t into ut. So this is our yt. So let us discuss another problem. So again the differential equation is defined by the following. A system is defined by the following differential equation. So differential equation is given as d square y divided by dt square plus 5 dy divided by dt plus 6 into yt is equals to xt. So the differential equation is given as d square y divided by d2 square plus 5 into yt plus 5 dy into dt plus 6 into yt is equals to xt. And the xt, so let xt be a rectangular, pulse, and it is defined as ext is equals to 1 between 0 is less than t and less than 2, so it is between 0 and 2. When t is between 0 and 2, it is 1, otherwise it is equals to 0. So this is our xt, this is our xt. So between 0 to 2, the value is 1, and all other values it is equals to 0. So this is the rectangular pulse. And also assuming that y0 is 0 and dyt divided by dt at t is equals to 0 is 0. So basically y0 is 0 and y dash 0 is also 0. That is given in the question. Now we need to find out the Laplace transform of yt. So find out the Laplace transform. Find out the Laplace transform of yt. Okay, so let us solve this problem. So Laplace transform of yt, let it is denoted as ys. So we need to find out the value of ys. So again I am writing the differential equation. So the differential equation is d square y divided by dt square plus 5 dy divided by dt plus 6yt is equals to xt. So this is the differential equation. So we can take the Laplace transform on both sides. So taking the Laplace transform on both sides, so d square y divided by dt square plus 5 dy by dt plus 6yt is equals to Laplace transform of xt. Then the Laplace transform of this term is s square ys minus 0 minus 0. Why? Because s y is 0 minus is 0 and y dash 0 minus is also 0. And then 5s into ys, because all initial conditions are equal to 0. That's why I have written this. And the Laplace transform of xt is xs. So s square plus 5s plus 6 ys is equals to xs. So ys is written as xs divided by s square plus 5s plus 6. So this is the Laplace transform. Now what we need to find out? We need to find out the value of xs. We need to find out the value of. So further we can write it as xs divided by s plus 2 multiplied by s plus 3. Now we need to find out the value of xs if we want to find out the value of ys. So what is xs? So let us see what is xs. So the xt is given as, so this is xt. So between 0 to t the value is 1. So this xt is written as ut minus 2. So basically if we consider a ut, then this is ut, and at 2 we can apply another ut, and this will cancel out, the area will cancel out. So finally we will get a box. So between 0 to 2 that box has value 1 and all other values it is 0. So what is xs? So xs is nothing but the Laplace transform of ut, that is 1 by s, and the Laplace transform of ut minus 2, that is e raised to the power minus 2 divided by s. So it is 1 minus e raised to the power minus 2s divided by s, that is xs. Now we can put this value of xs in ys, and we will get ys as 1 minus e raised to the power minus 2s divided by s plus 2, s plus 3. So this is the Laplace transform of ys. This is the Laplace transform of ys. So let us do another problem, and the problem is an input xt is given. An input xt is given. An input xt is given as xt is equals to ut ut exponential minus 2t plus del t minus 6. So this is xt, that is the input. The input is given, it is equals to exponential minus 2t into ut, and that it is applied to an LTI system. So this input is applied, this input xt is applied to an LTI system, that is linear time invariant system, with impulse response ht is ut. With impulse response ht is equals to ut. We need to find out the output yt. So we need to find out the value of output yt. Find out the value of output yt. So let us solve this problem. So input is given, and the input is xt, that is equals to exponential minus 2t into ut plus del t minus 6. So the input is given. So the Laplace transform of this input is 1 divided by s plus 2 plus e raised to the power minus 6s into 1. So it is 1 plus e raised to the power minus 6s divided by basically we can just write it in this form, divided by s plus 2. So this is excess. So it is better to write in this form. So it is more suitable. Now that impulse response is also given. That impulse response is given as ut. So it is equals to 1 divided by s. So the Laplace transform of this impulse response, that is system transfer function. So hs is 1 equals to 1 divided by s, and that is nothing but the transfer function. And this ht is the impulse response. So what is happening here? We have a LTI system, and the input is given, that is xt, and we are getting the output yt, and there is impulse response ht. So xt is given, the ht is given, the ht is given. So we need to find out yt. So this is our problem. So xt is the Laplace transform, that xs is given, xt is given. So xs is basically the Laplace transform of xt, and it is equals to 1 divided by s plus 2 plus e raised to the power minus 6s into 1. That is the Laplace transform of this term. And it is just we have combined these two terms, and this is our xs. Now hs is also given. So that ys is hs multiplied by xs. So ys is hs multiplied by xs, and it is equals to we can write it as e raised to the power minus 6s divided by s plus 1 divided by s plus 2. So this is ys. Now suppose this is y1s plus y2s. This ys we can write it as y1s and y2s. So y1s is e raised to the power minus 6s divided by s, and y1t is written as ut minus 6. Please check this. So y1t is ut minus 6. So please check this, and we can solve y2s also. So y2s is equals to 1 divided by s plus 2, and that we can write it as a divided by s plus b divided by s plus 2. So what is a? So a is s into y2s at s is equals to 0, and it is equals to s multiplied by 1 divided by s plus 2 at s is equals to 0, and it is equals to 1 divided by 2, that is 0.5. And what is b? So b is equals to, the v is equals to s plus 2 multiplied by 1 divided by s plus 2 at s is equals to minus 2. So b is equals to minus 0.50. Please check. Now y2s is equals to 0.50 divided by s minus 0.50 divided by s plus 2. So this is y2s. Now ys is written as 0.50 divided by s minus 0.50 divided by s plus 2 plus e raised to the power minus 6s divided by s. So yt is equals to 0.50 ut minus we can put 0.50 outside, e raised to the power minus 2t into ut plus ut minus 6, and we can write in this form, we can write in simplified form as 1 minus e raised to the power minus 2t into ut plus ut minus 6. So this is the output yt. So this is the output yt. This is the output yt. So let us solve another problem that is also related to the continuous time LTI system. So let us discuss the another problem. So the problem is a continuous time LTI system is described by a continuous time LTI system is described by d square y divided by dt square plus 4 dyt divided by dt plus 3yt is equals to 2 dxt divided by dt plus 4 into xt. So this is a continuous time LTI system, and it is described by the second order differential equation, that is d square yt divided by dt square plus 4 dyt divided by dt plus 3yt is equals to, that is 3yt is equals to 2 dxt divided by dt plus 4 into xt, and it is assuming that all initial conditions are equal to 0, and it is assuming that all initial conditions are equal to 0. We need to find the response of the system. So the question is, find yt when axt is equals to e raised to the power minus 2t into ut. So we need to find out the response of the system when input is provided and input is given as xt is equals to e raised to the power minus 2t into ut. The input is given. Now we need to find out the output yt, that response of the system yt. So it is given that all initial conditions are 0. So it is given that all the initial conditions are equal to 0. So applying the Laplace transform in this equation, so it is equals to s square ys plus 4 sys plus 3 ys is equals to 2x 2s xs plus 4 xs. So this is the Laplace transform of this differential equation. So we can combine all these x ys terms. So it is s square plus 4s plus 3, and that is equals to 2s plus 4. So what we will find out? Ys divided by xs, and that is equals to 2s plus 4 divided by s square plus 4s plus 3, and that 2 we can take common, so it is 2s plus 2 divided by s square plus 4s plus 3. So this is our ys divided by xs. Now this xs is equals to Laplace transform of xt, and xt is given, so we need to find out the Laplace transform of xt, and xt is given, it is equals to e raised to the power minus 2t into ut. So the Laplace transform of this is 1 divided by s plus 2. So the Laplace transform of this is 1 divided by s plus 2. Now we can use this xs in this equation. So this is equation 1, this is equation 2. So using 2 in 1 we obtain ys is equals to we can use this relation. So we will obtain ys is equals to 2s plus 2 divided by s square plus 4s plus 3 multiplied by 1 divided by s plus 2. So this will cancel out, so it is equals to 2 divided by s square plus 4s plus 3. So further we can solve it. So ys is equals to further we can solve this. So what we will get? We will get 2 divided by s plus 1 s plus 3 is equals to a divided by s plus 1 is equals to a divided by s plus 1 plus b divided by s plus 3. So we can just find out the value of a and b. So a is s plus 1 into ys when s is equals to minus 1, and that is equals to s plus 1 2 divided by s plus 1 s plus 3 at s is equals to -1. So what we will get here? We will get 2 divided by -1 plus 3. That is equals to 1 only. Now similarly we can find out the value of b. So b is s plus 3 multiplied by ys at s is equals to -3. So that is equals to 2 divided by s plus 1 at s is equals to -3. That is equals to 2 divided by -2, and it is equals to -1. So what we will get here? We will get ys is equals to 1 divided by s plus 1 minus 1 divided by s plus 3. And finally, if we find out the inverse Laplace transform, so it is e raised to the power -2t into ut minus e raised to the power -3t into ut. So yt is given as e raised to the power -t minus e raised to the power -3t into ut. So this is the value of yt. So this is the value of yt. So let us do another problem. So it is given that fs is one-sided. Laplace transform of ft. Laplace transform of continuous time function ft. So find out the Laplace transform of 0 to t ef tau d tau. So what we need to find out, so what is given in the problem? It is given that fs is given, and that is nothing but the Laplace transform of ft. So fs is given, that is nothing but the Laplace transform of ft. So we need to find out that the value of 0 to t f tau d tau. We need to find out this value. Now according to the definition of this Laplace transform, so this 0 to t f tau d tau is nothing but it is equals to fs divided by s plus f minus 1 f inverse 0 plus divided by s. So since this is 0, so what we will get? We will get fs divided by s. Since we see it is 0, so we will get fs divided by s. Why? Because f inverse 0 plus is equals to 0. Because initial conditions are equals to 0. This is because initial conditions are equal to, because initial conditions are equal to 0. Let us discuss another problem. So the next problem is it is given that the Laplace transform of continuous time signal is given. It is given as xs is equals to 59s divided by s square minus s minus 2. So it is given that 5 minus s divided by s square minus s minus 2. So xt is a continuous time signal. And the Laplace transform of xt is given as xs. So if the Fourier transform of signal exists, then what is the value of xt? Then the problem is, if the Fourier transform of signal xt, if the Fourier transform of signal xt exists, then find out the continuous time, find out the continuous time signal xt, find out the continuous time signal xt. So let us solve this problem. So xs is given. So what is xs? Xs is 5 minus s divided by s square minus s minus 2, and it is given that the Fourier transform exists. So by doing the partial fraction analysis, we can find out that we can simplify this. So xs, we can write it as s square minus 2s plus s minus 2, and it is equals to 5 minus s divided by s, we can take common, s minus 2 plus 1 s minus 2, so that xs is written as 5 minus s divided by s square minus s minus 2. It is equals to basically that 5 minus s divided by s plus 1 and s minus 2. So it is written as s plus 1 and s minus. It is equals to a divided by s plus 1 plus b divided by s minus 2. Now what is a? So a is s plus 1 multiplied by xs when we are taking s is equals to minus 1. So it is equals to 5 minus s divided by s minus 2 at s is equals to minus 1, and it is equals to 5 plus 1 divided by minus 3, and it is equals to 6 divided by minus 3, that is equals to minus 2. So a is equals to minus 2. Now b is s minus 2 multiplied by xs at s is equals to 2, that is equals to 5 minus s divided by s plus 1 at s is equals to 2, and that is equals to 5 minus 2, so it is 3, and 2 plus 1, that is also equals to so 3, so 3 divided by 3 is equals to 1. So what we get, so we get xs is equals to minus 2 divided by s plus 1 plus 1 divided by s minus 2. Now the condition is provided, the condition for region of convergence is that the region of convergence includes the j omega axis. Why I am saying this? Because when ROC will include the j omega axis, that means s is simply j omega. So it means that the Fourier transform exists. The Fourier transform will exist, because when the Laplace transform will include the j omega axis, in that case only the Fourier transform will exist. Now let us discuss the various cases. Let us discuss the various cases. So the xs is given as minus 2 divided by s plus 1 plus 1 divided by s plus 2. So let us consider this is non-causal. Let us consider this is non-causal, and this is also non-causal. So if both are non-causal, then what we will get, there is a pole at -1 and there is a pole at, sorry, this is -2, s -2. Okay, this is -2. So if this is non-causal and this is also non-causal, then this is pole at -1 and there is pole at 2, because we have poles at s is equals to -1 and s is equals to 2. Now, so this is sigma and this is j omega. This is sigma and this is j omega. Now, if both are non-causal, it means this signal will give the real part of s is less than -1, and this signal will give the ROC, that is real part of s is less than 2. So this will give real part of s is less than -1 and this will give the real part of s less than 2. So for this, if it is non-causal, then this is the ROC, and for this signal, the ROC should be look like this. So this is the ROC. So basically the overlapping region, so basically the common ROC is nothing but it is real part of s less than -1, means left to the leftmost pole. So this is the leftmost pole. So the ROC is real part of s less than -1. It means it is left to the leftmost pole. So the ROC, the common ROC is left to the leftmost pole. But the important point is that this ROC is not included the j omega axis, and this ROC not included j omega axis. So this ROC not included the j omega axis. It means both signals are not non-causal. That first condition is not true. So let us discuss another condition. So let us take that we have -2 divided by s plus 1 plus 1 divided by s minus 2. So let us take that this signal is causal. This signal is causal and this signal is also causal. So if both signals are causal, then what are the poles? So poles are x is equals to -1 and s is equals to 2. So we know that if the both signals are right-sided, then the ROC will be right to the rightmost pole. So this is the ROC. That is, since both signals, let this is x1 as and this is x2 as, since both signals, the Laplace transform of both signals x1 as and x2 as are are basically causal. Okay, so what it means that the ROC is right to the rightmost. The ROC is right to the rightmost pole. It means in this case also. So in this case also, the ROC does not include the ROC does not include the j omega axis. So the Fourier transform. So the Fourier transform will not exist. So the Fourier transform will not exist for this case also, because the ROC is not included the j omega axis. Now let us discuss the third case. So xs, that is x1s plus x2s, and it is equals to minus 2 divided by s plus 1 plus 1 divided by s minus 2. Now let us discuss this case and consider it as causal signal. And consider this as non-causal signal. So consider this signal as causal signal and consider this signal as non-causal signal. Then if it is a causal signal, then the ROC is, this is sigma, this is j omega, then the ROC is real part of s greater than minus 1. So this is minus 1, then it is a real part of s greater than minus 1. And then we have non-causal signal. So this signal we have non-causal. We have considered that this signal is non-causal, and the pole is s is equals to 2. So basically, if it is non-causal, then the real part of s should be less than 2. So there is a 2 here, and the real part of s should be less than 2. So this is the ROC. Now if we find out the common ROC, then this is minus 1 and this is 2, this is sigma, this is j omega. Now this is the common ROC. So what is the main point is that the common ROC includes the j omega axis. So the Fourier transform will exist because the common ROC includes the j omega axis. So the Fourier transform will exist, and the common ROC is 2 real part of s is less than 1. So this is the common ROC, because the common ROC includes the j omega axis. So what is xt? So xt, since first signal we are considering as causal, so please check, this is minus 2 e raised to the power minus t into ut, and the second signal is causal, so it is minus e raised to the power 2t into u minus t. Please check this. So this is our final answer. So let us discuss another problem. That is also based on the matching of some transformation and some concept. So match each of the items 1, 2 on the left with the most appropriate item A, B, C, D on right. in case of linear time invariant system. In case of linear time invariant system, that is LTI system, poles in the right half S plane implies, so the poles in right half of S plane implies and exponentially decay output second one is impulse response 0 for, so first is poles in right hand plane of right hand side of S plane implies, this is the first point. Second point is impulse response impulse response 0 for P is less than or equal to 0 implies. So we have to match with A, B, C and D. So what is A, B and C? A, B, C, D. So it is first A is exponential decay output. The point B is system is causal. The point C is no stored energy in the system. And point D is system unstable. So if we just see that what is the solution of this problem, if we just see that the first is that A is first one is that the poles in the right half of S plane. So poles in the right half of S plane means if the pole exists in right half of S plane, it means the system is unstable. So for example, if xs is 1 divided by s plus 2, then xt is nothing but e raised to the power 2t into ut, and it is growing, it is exponentially growing. So basically the system is unstable, system is not stable. And what is the second point? The second point is that the impulse response 0 for t less than or equal to 0. So it means that the system is causal. The system is causal. If the impulse response is 0 for t less than or equal to 0, it means that system is causal.